So that's me drilled most of it out. We've matched up the bolt-on shaft, and as you can see here, it moves nice and free, so it's absolutely spot on. And then what we've done is, rather than using hex bolts, we're going to be using Allen bolts in it. So with the other one I've already countersunk the holes for that, so that the Allen head will be recessed in there. And this is going to be machined down as well, the outside surface, so the holes will be on a taper, and obviously that matches up with the other one which has been drilled and tapped as well. So there we have the two of them so far. We'll push on and show you it as it progresses. So here it is here. I'd left the sort of margins in the material I cut to see whether I was going to leave this as a straight edge or a taper. I think I prefer it as a taper, so I'm just going to leave it at that. And now we'll go on and boring it. We're going to bore it so that, there we go. So that's going to go into there. That'll be bored. Excuse me, sorry, I was looking at the job rather than the camera lens. So that's going to fit in there and leave us a lip for a weld around it. And say it will sit in there about 20mm, 3/4 of an inch, around about that sort of depth, probably about there. And, yeah, and the bolt heads will just, you know, the Allen bolts will just fit in there like this. So it should make it quite pretty, as well as functional. Both important when you're building custom motorcycles. Right, we'll push on with it. Right, so that's this one finished. What I've done is I've bored it out. I'll just swap hands here. I've bored it out for, I've showed you that I'm going to use two tubes together as the shaft, so I've bored it out as a seamless 1/16", and it will go right through into the face in there, where it will be welded in here. And I've got the ERW tube, which is a larger size, which is going to go outside there. And as I said, with a wee bit of machining, these two will go together, so they'll be welded as well. So it's just adding, rather than just catching this outside tube itself, it will also now, although these two will be welded together, it will also independently get a weld around the front there. So there's the first one machined and bolted onto the sprocket. Now I've opened out the back of it here, and simply what that's for is of the two tubes that I'm putting in, one will go right in down to the face, and the second tube goes flush on the outside and will be welded around this edge, and then obviously the opposite at the other end. So certainly looks way prettier with a taper on it than it does just all squared off. So we're going to push on, do the same with this one now, and then we can get it lined up on the actual bike itself. Right, so all that remains now is for me to locate the bearing into the sprocket. Now, to make sure that goes in nice and square and I don't have any aggro with it, what I've done is I've made up this drift. It's got a 20mm shaft on it, so it slides through the bearing, and it's just a fraction under the width of the actual bearing itself. And obviously this is a slightly bigger hole in here. If this is picking it up, you can see it can move. So that it centres on that as well, I've made up this sleeve, and it just fits in there. There's a wee spacer under it now, so that it's a bit raised. That then locates into that, and it will mean that the bearing will be sitting perfectly square for chopping in. Okay, just thought I'd show you that. Yep, and here you can see that I've drilled 3 holes so that it makes it easier for chopping the bearings out if the bearings ever need replaced on this. It's easy done now rather than trying to hammer the bearing out, especially if you're just using the centre part of it, because then you'll destroy the bearing anyway. So it's easy enough to drill 3 5mm holes, which is just under 1/4 inch. So I just thought I'd show you that before I start assembling it and putting the bearing in. I have also made up. So here you see the inner tube, or the outer tube and the inner tube. What I'm doing is I'm welding these with 3 spot welds right through the outer tube to join the 2 of them together. And this is because this outer tube is going to be welded to the outer face here, but inside you can see that inner face through there, the light edge, and that's where this part of the face is going to be welded there. So it's just to tie the 2 of these together so that they're working as one unit. So that's the reason that that's getting done. Right, because the forces on the JackShaft are sort of torsional, as in they're wanting to spin and break the weld on the other side, one of the ways to stop anything turning is to do what I've done here. If you can, the camera's picking that out, is to actually drill so that it's catching the side of the pipe, as you can see here before I've threaded this one, and then put in a grub screw, and then I'll put a tack on top of this so that the grub screw can never come out. And basically this means that unless this pipe completely collapses, it will be unable to spin. So it's quite a good way of locating it rather than just welding it in place. So I just thought I would show you that. Right, that's both of them drilled and tapped. What I'm using here is a 5mm, which is just under 1/4 inch by 12mm long, which is just under 1/2 inch Allen bolt, or Allen grub screw, sorry, on both sides. So that should work absolutely perfect there. Right, we'll push on, get on to the other side now. Right, before I bolt the other side in, I just wanted to also show you this wee jig, which I knocked up very quickly. It's really good for holding the sprocket to stop it twisting, and also it's got a height that it allows me to knock the bearing out sitting it on a solid bench. And as you can see here, there's the 3 holes that I drilled to allow a punch to go down there to knock it out. Finally, one of the most important things to do when you're actually doing this, well, everything's quite important, is actually this thin piece of tube here. And what it does is it actually sits right to the inside, the spindle runs through this, and it applies a very light pressure to the inside of the bearing. Basically this piece here, when it sits on it. See if you can actually see this. I'll move it under the light a wee bit. Yep, so it applies pressure right onto the inside bearing, so that when you've got it clamped in the adjusters, the spindle doesn't push this centre inside and therefore clamp up the bearing itself and make that rigid. It just touches the inside face on both sides when it's all clamped up nice and tight. Takes a wee bit of trial and error just to get it right. I was machining thousands off at a time just to make sure I got it spot on, and that's really it. Just now to bolt the 2 together and stick it all back on the bike. But yeah, it's worked out really well. As I say, I might do these as a kit form, we'll wait and see, but I'm happy with it, and so is my customer, so that's the main thing. And last but not least, want to mention the Allen bolts that I'm using to hold the sprockets on with. These are 6mm by 30mm long, which is roughly 1/4 inch by about 1.25 inches, and they are high tensile 12.9. I'm not going to zoom in because you won't be able to pick it up in the face. I'm not Loctiting these in initially because the chap might want to take this off to paint it or whatever else, so I'm just putting these in and tightening them up. But on final assembly, I would recommend that these are Loctited in place as well, so that obviously these don't vibrate loose either. So that's it really for the JackShaft. I'll show you it when it's finally assembled back on the bike again, and we'll push on now.